Welcome to Better World here at MIT.
I'm Jason Pontin. I am the editor-in-chief and publisher of Technology Review, which is MIT's magazine specializing in innovation. We have an amazing panel this morning where we will explore taking technologies from lab to the market, the actual process of commercializing the innovations that can change the world.
To the wise among all of you entrepreneurs is don't gauge the rate at which you're going to be that instant success by how quickly you can develop a technology. I would gauge it by how long it takes the collective culture, any culture, to give up something, even something they're frustrated or unhappy with, and accept something different.
Pasteur was not doing science for science. Pasteur was trying to save lives. He was trying to look at why did food go bad. He was doing a practical problem, but he was doing it in a fundamental and principled way. And I think that that's the change that's coming to science. You see it spreading throughout MIT, and it's what we hope to do at the Media Lab.
In terms of our actual venture conception, we like to take even a step further back, where there's actually no technology, and say, okay, what are the big problems of the world? And where do we stand from a technology standpoint? Can we find a way to overlay these and build a great company out of that? And it turns out the companies that we've engaged and the companies we've built in that manner, whether or not we've put someone from our team in as an entrepreneur, turn out to be the ones that have generated for us the greatest returns.
The mobile phones have spread all over the world. And it's strangely, in places where there is no water, or at least potable water, electricity, many other basic necessities aren't there. But mobile phones are there. Why is that the case? Isn't it a little puzzling? So I just wanted to explain to you why. One is that it's a productivity tool. It helps people waste less time, less opportunities, so they get more things done. So if by doing that, people have the ability to pay, that's the point I was making. And as a result, companies can provide these tools, and they can profit. And that's how billions of dollars are being invested.
Should we even try to change behavior? And I think when we originally were thinking about that, sometimes it seems really paternalistic for me to say, I want you to behave very differently. But I think that it becomes a much more clear, resounding yes once you think about behavior change as first starting with understanding where someone's values are coming from, and so that you can really try to say, I actually want to help you live out your values better.
It is certainly true to say that cancer is an extraordinarily biologically complicated problem. Every one of us, when we have cancer, develop it in a very unique way. The genetic mistakes that evolve in each of us individually are quite unique and have historically led to a very difficult time in figuring out what to do about it, how to treat. But in this moment, we're moving into an era where genome sequencing and our ability to really understand the underlying biology are moving at an unprecedented pace. We're going to be able to sequence genomes at a fraction of the cost, and in fact at levels that are quite compatible with conventional diagnostics. And so our ability to take this 35 years of taxonomy, if you will, of really cataloging what causes cancer and translate that into new ways of intervening, we believe represent a very important moment in history. And it's really this moment that has led us at MIT to launch something like the Koch Institute.
The face of cancer is actually changing worldwide, and we need to change the way we think about approaching this from a technological perspective to make it more affordable and more effective to treat tumors.
What are the key requirements to build innovative companies? Really three things. You have to create the innovative environment, protect the innovation, and fund the innovation. You have to recruit top scientific talent that are absolutely committed to scientific excellence. The reason that the scientists are in this game is to translate the science to products, and that has to be the motivating driver, the passion to make this happen.
We have found a set of success stories and we've described them. And I think that's extremely important and very informative, and also probably the most inspirational we can be.
There are 6.8 billion people on the planet today, which stresses the carrying capacity of this ecosystem. And by 2050, there will be 2.5 billion more people on the planet. So that creates opportunity and it creates tremendous challenge. Now, several billion of those people are not energy consumers at all today. But within the next 10 years, billions of them will transition from bicycles to scooters, for instance. Multiplied by 1 billion, that's a big additional pull on energy resources planet-wide, and we're going to have to adapt to that.
The whole X Prize was put in place to try to say, let's create a new culture of 100 mile per gallon plus vehicles, and let's put a $10 million prize out there for companies that will innovate and take new technologies and move us forward, because quite frankly, I'm a recovering Detroit automotive executive. And we're stuck in a paradigm. And so how do you break through a paradigm? Well, you break through with a disruptive technology.
How do you educate youth for the green economy? Our answer is by competing in national competitions and implementing project-based learning. We are one of the top competitors in the $10 million Progressive Insurance Automotive X Prize competition.
Today's solar cells, the best solar cell that you can buy to put on your house, silicon-based, is about 19% efficient. So we're looking at 19% compared to about 29% is the maximum efficiency we could get from a silicon solar cell. So the idea is that if we can do as well with something that was maybe an intermediate band solar cell as we are doing today with our classic single gap solar cells, then we could effectively double our current efficiency, which would bring us pretty much to grid parity for cost of electricity delivered via solar.
If you're poor, you die a lot more if it gets really hot or really cold. The absence of energy services, the point is, really means something to the way people live.
NSTAR alone is essentially building a 400 megawatt plant, or as I like to say, megawatts. That's literally what I'm building in 3 years. Now, if you were trying to site and build a natural gas plant, you couldn't do it in 3 years for 400 megawatts. But what we're doing is creating savings, little distributed generators all across in people's homes and businesses, saving energy by improving the building shell, by improving the heating and cooling equipment and making it more efficient. Lighting is a huge benefit. We're at 3 cents. 3 cents a kilowatt hour as opposed to 7 cents on natural gas as opposed to 45 on solar.